Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Hero to Superhero series on Python machine learning algorithms. Alright guys, so this is a pretty interesting series. We have crossed almost 13 different algorithms and now it's time to learn about LSTM. Wow, this looks little different. So what is LSTM? LSTM stands for long short term memory. It's basically a recurrent neural network RNN based architecture that is widely used in natural language processing and time series forecasting. It's a pretty complex algorithm though, but there are ton loads of machine learning and deep learning projects being built on LSTM. LSTM basically rectifies a huge number of issues or a problem that is actually recurrent neural networks suffer from short memory. So, for example, using a series of gates, each with its own RNN, that is the recurrent neural network, the LSTM manages to keep, forget, or ignore data points based on the probabilistic model. I know it's getting confusing, but I'm there for you guys to handhold you systematically and explain you one-on-one how this algorithm works and execute on your machine itself. So basically, LSTM also help you to solve exploding and vanishing gradient problems. I know if you guys are from ML, AI industry, you will definitely understand what is this exploding and vanishing gradient problems. I'm not going to talk about that, but if you need more details you want to learn, I'm there for you. Reach out to me. In simple terms, these problems are a result of repeated weight adjustments from the output of the neural network, and then as a neural network trains, you just got to adjust the weights again into the input. With repeated epochs, that is the number of iterations you run the data to get trained, the gradients become larger, either larger or smaller, it depends. And with each adjustment of the weight, it becomes easier for the neural network gradients to compound in either direction. Now this compounding either makes the gradients way too larger or way too small. It all depends upon the size of the data you are going to feed into the network, right? While exploding and vanishing gradients are huge downsides of using traditional recurring neural network, the LSTM architecture severely mitigates these particular issues. That's where the advantage of this particular LSTM algorithm. Now enough said, let's take a look at the code and see what's happening. So let me move on to my IDE. There you go. So this is the code. So we are obviously using NumPy, Pandas and scikit-learn, and of course we are also going to use the TensorFlow and Keras. So that is very important because this requires certain neural network models to run within the algorithm. So we are going to use the Google TensorFlow stuff as well. And let's see, the number of lines is just about 51 lines of code. I'll be happy to share this code with you guys to execute this particular LSTM prediction algorithm. And you can play around with your machine learning project. So, feel free to reach out to me. I'll be happy to assist you. Until then, see you in the next algorithm. Goodbye.